All right, so here we're supposed to, if possible, use the graph to evaluate each expression, then use the formula f of x to check the results. Okay, so we're supposed to find f of 0 from the graph and f of 3. Easy enough. F of 0. Well, 0 is x equals 0, so that is equal to what? Well, that's equal to a negative 1 for y. And if we find 3 for x, we go over here to 3 and we go up to here, so that looks like a 5. Now we check it. What is f of 1, or 0 rather? I was looking at the negative 1 up there. All right, so f of 0, we plug in 0 here, we get a minus 1 plus 2 times 0. Well, that's minus 1. And f of a 3 is going to be equal to a minus 1 plus 2 times 3. Well, 2 times 3 is 6, minus 1 is 5. Well, that checks with that one. That checks with that one. So they work both ways. So basically, what we can say is that really is the function, at least it looks like, for what's given here. All right, so now we have f of 1 and f of minus 1. Okay, well, let's start with f of 1. Well, x equals 1 is here. We go up here, that's equal to a 3. Okay, so that one works. Now, minus 1. Minus 1 is here, and nothing that direction, and nothing that direction. And so that one basically is going to be not possible. Okay. Now, does that fit with what the equation over here says, or the function? 6 over, and then we have 1 plus 1, and 6 over 2. 6 divided by 2 is 3. That works. What about f of minus 1? We have 6 over minus 1 plus 1. Well, that's 6 over 0. That's not possible. And that's the case. And when we graph these, what would happen is when we're looking at this, we would normally say, okay, well, let's find our domain. Well, our domain is going to be all x except for x cannot equal a negative 1. So it cannot equal that, and because it cannot equal that, when you come over here, it's not possible. And so what that usually happens is we usually have, when we're drawing this, we have the dotted line showing that it's not equal here when we actually draw out a graph. And so if I could just follow the line, it'd be even better, but that's okay. So that's really usually what happens. All right, let's stop there and we'll come back for some more.